morning, students. Today we are going to see MO energy level diagram for O2 molecule. See, this O2 molecule is formed by the combination of two oxygen atoms. That is, one oxygen atom plus second oxygen atom. There is formation of O2 molecule. This oxygen have atomic number 8. Its electronic configuration is 1s2, 2s2 and 2p4. See, oxygen atom, two oxygen atoms combine to form this O2 molecule. There is combination of atomic orbitals of one oxygen and atomic orbitals of second oxygen. See, atomic orbitals of first oxygen at one side, atomic orbitals of second oxygen at another side, they combine together, and from the oxygen first, one oxygen, it provides 1s or 2s and 2p orbitals for the combination. Second oxygen also 1s, 2s and 2p combination. 1s orbital combines with 1s orbital, 2s orbital combines with 2s orbital and 2p orbitals combines with 2p orbitals. See here, 1s orbital of both combines and they give the two molecular orbitals. One is the sigma 1s orbital, which is the BMO, and second sigma star 1s orbital, which is higher in energy, it is called as the ABMO. Similar is for the 2s orbitals. Two 2s orbitals get combined. There is formation of one sigma 2s bonding molecular orbitals and sigma star 2s anti-bonding molecular orbitals. Bonding molecule have the lower energy, anti-bonding have the higher energy. Then 2p orbitals of both oxygen atoms combines. Here 2px orbital of the first oxygen and 2px orbital of the second oxygen, they get combined and they give the sigma 2px BMO and sigma star 2px ABMO, which is sigma 2px have the lower energy, sigma star 2px have the higher energy than the atomic orbitals. Then the remaining two orbitals, that is 2py and 2pz, they combines with the 2px and 2py orbitals of the second oxygen and they use the pi bonding and pi anti-bonding molecular orbitals, that is py use the pi 2py and pi star 2py. Pz orbital gives the pi 2pz and pi star 2pz orbitals. Both have the equal energy, so this sign indicates that they have the equal energy. Pi 2py equivalent energy pi 2pz, pi star 2py equivalent energy pi star 2pz. See, in this combination, in the previous diagram of N2 molecule, we see that in the combination of p orbital, the energy of sigma 2px is higher than pi 2py equivalent energy pi 2pz orbitals. This is because in nitrogen, see, in case of the N, there is atomic number is 7, electronic configuration is 1s2, 2s2 and 2p3. That is, here is the 2px, 2py and 2pz, 1, 1 and 1. But when we consider the oxygen, it having the 1s2, 2s2 and 2p4. Here that is 2px, 2py and 2pz. Here there is the 2, 1 and 1. It is the electronic configuration. When we see in this nitrogen, see here there is the 3 orbitals. So 1, 2 and 3. See, in case of the oxygen, there is the 1, 2 and 3. And then pairing will be start. Then here pairing will be start. So difference in nitrogen and oxygen is that in the pairing. Here it will be get pair. See, in case of the nitrogen, when we consider the 2px orbital, it having the this 2px orbital have the interaction with this 2s orbital because it is empty, it is a single unpaired electron. Unpaired electron can show the interaction with the 2s orbital. So here it is the sp interaction, and due to sp interaction its energy will be increases, and it shows the higher in energy, it shows lower in energy in case of the nitrogen. But in case of the oxygen, see here there is the pairing, and when we consider here there is the pairing, now this 2px it will be get paired. As the it will be get paired, its interaction will become the less, and so there is less sp interaction. Here there is the less sp interaction, less sp interaction. Due to the less in sp interaction, what will happen? Its energy will be dropped down. Its energy will be dropped. See on this energy axis, energy from here it will be get drop here, and here there is the change in the diagram. That is the position of sigma 2px is at lower, while position of pi 2py equivalent energy pi 2pz is at the higher level. Then we are going to see there is the particularly electrons, how they will be filled into the molecular orbitals. See the atomic orbitals of the first oxygen, its electronic configuration 1s2, 2s2 and 2p4, 1, 2, 3 and 4. Same is the case for second oxygen, 1s2, 2s2 and 2p4, 1, 2 and 3, and then there is the 4. See, as these atomic orbitals they will be vanished, there is formation of the new molecular orbitals, automatically electrons will be enter into the molecular orbitals which are formed here. See, in case of this 1s combination, there are 2 electrons from first 1s and 2 electrons from the 1s of the second oxygen, and see here there are the 4 electrons, 1, 2, 3 and 4. Same is the case for 2s orbital. There is the 1, 2, 3 and 4. Now, in case of the p orbital, first oxygen have the 4 electrons, and second oxygen have the 4 electrons in p orbital. Now there are 8 electrons, and that 8 electrons will be enter into the molecular orbitals accordingly. See 1, 2, 3, 4, 5, 6, now there is the 7 and 8. See here, it is the particularly fulfilling of the electrons into molecular orbitals. Now, MO energy level diagram shows the such type of the picture, and now we are going to see this O2 molecule can exist or not. This O2 molecule. See, for this we must have to calculate the bond order. See the formula for the bond order. Bond order is equal to half in bracket electrons in BMO minus electrons in ABMO. See electrons in BMO. Now calculate the electrons in BMO. See here it is the BMO, it is the BMO, it is the BMO. So how many electrons? 2 plus 2 and plus here there are the 6 electrons. So total there are 10 electrons. In BMO there are total 10 electrons. Minus now ABMO. See the ABMO. Here 2 electrons, 2 electrons and here now 2 electrons. So that total there are the 6 electrons. See here minus electrons in ABMO 6. See it will be, that is the 4 minus 4 upon 2 is equal to 2. Here bond order is 2. Bond order is 2 indicate that there is double bond between 2 oxygen atoms in O2 molecule. Here there is the 2 bonds, that is the double bond between oxygen atoms. Is this molecule will be stabilized? Yes, this molecule will be get stabilized, and for this you should have the stabilization energy. So calculate the stabilization energy or energy you hold during the formation of molecule. It can be calculated as electrons in BMO into minus beta plus electrons in ABMO into plus beta. We know how the electrons in BMO. How many? There are the 10 electrons into minus beta plus ABMO have the 6 electrons. So 6 into plus beta. Total is equal to, there is the 4 beta minus 4 beta. See, this minus 4 beta is the stabilization energy. See, there is a double bond between the oxygen atom. Molecule is stabilized by minus 4 beta amount of energy. Thus, molecule can be exist. Molecule can be formed. It will be get stabilized. Now, we are going to see the magnetic behavior. In case of the magnetic behavior, see, if there are the unpaired electrons, then molecule is paramagnetic. See, in case of the oxygen atom, there are two unpaired electrons in antibonding pi 2py and pi 2pz. That is, there are two electrons in pi star 2py, equivalent energy pi star 2pz. This indicates that O2 molecule is paramagnetic. O2 is paramagnetic. So this O2 molecule is paramagnetic. Always there is question. Explain the paramagnetism of O2 molecule. At that time, you should have to draw this diagram, calculate bond order, calculate energy, and show that there are the two unpaired electrons in antibonding molecular orbitals, and due to that, this molecule is the paramagnetic. Its molecular orbital electron configuration. So O2 molecule have its molecular orbital electronic configuration. See, here it is the sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, and then there is the sigma 2px. Here there is the sigma 2px. See, sigma 2px2, then pi 2py2, pi 2pz2, and pi star 2py1, equivalent energy pi star 2pz1, and sigma star 2px. It does not have any electron. So MO energy level electronic configuration: sigma 1s2, sigma star 2s1, 1s2, sigma 2s2, sigma star 2s2, sigma 2px2, pi 2py2, equivalent energy pi 2pz2, pi star 2py1, equivalent energy pi star 2pz1, and sigma star 2px. It does not have the electron. So it is the molecular orbital electron configuration. See, when we consider the O2 molecule, this O2 molecule, its paramagnetic nature of the O2 molecule is important, and at the same time, this O2 molecule can use the different molecular ion. This O2 molecule can use the different molecular ion. Which are that molecular ion? See, this oxygen can use the molecular ion. It can use the molecular ions. So what that molecular ions? It can use O2 plus, it can use O2 plus plus, it gives the O2 1 minus and O2 minus minus. See, in this molecular ion, they have the different energy level diagrams. Their property will begin changes, and we are going to compare this molecular ions of the O2 with the O2 molecule. In next lecture, we are going to see this particularly the comparison of O2 plus